Smithsonian's National Museum of Natural History. This is the Okeanos Explorer. We're currently en route to the bottom of the seafloor on today's dive of Pierpont. Is that how it's pronounced?
Pierpont.
Pierpont Seamount. I'm here with my colleague, Chris Kelly.
Yeah, thank you, Chris. And we're your hosts today, as we have for some of the other dives on this cruise. Actually, all the dives on the cruise will be your hosts, the double Chris's. And this is the Okeanos Explorer, and our current depth right now is 1,240 meters. And if I'm not mistaken, we're going to about 1,600 meters.
You are not mistaken.
So we have 350 or so meters to go.
Something like that, yes.
Yeah. So for you oxyophiles, oxygen-loving people, we hit our oxygen minimum this morning going down right around, about 550 or so meters. So a little bit deeper than we saw yesterday. And I'm not sure if that's a trend. We're quite a bit further west. So who knows? As we go south, oxygen minimum goes shallower. But if we go west, maybe it goes a little deeper. I'm not really sure. Because this is the westernmost dive that we're going to be doing this cruise. And we're right on the western edge of, what is it called? It's the Pacific Nearby Islands Marine National Monument? No, that's not quite right, is it?
No. Chris, in fact, we are at the Pacific Remote Islands Marine National Monument.
It's remote.
A minute.
God,
so just
darn it,
be
I
ready?
should remember that. You know what? I just thought of a great way to remember that. Right? So it's like a remote control. Right? So if you're on one channel, then you're at the Johnston Atoll unit of the Pacific Remote Islands. Then you flip the switch, and you go to the next channel, and you're at the Palmyra unit of the monument. You flip the switch again, you're at the Kingman unit. You flip the switch again, and you're at the Jarvis unit. And then you switch it another time, and you're Howland and Baker. And then the final channel is Wake Island. So like whatever channel, whatever remote island unit that you want to go to, it's like a remote control. How's that for a way to remember it?
If anybody's listening now, you're just getting the gold cream of our material before we get to use it on prime time. So.
All right, so Kelly thinks we actually did forget how to say it, so she's given us little reminders. I'm afraid we kind of pre-planned this whole thing.
Copy bridge, thank you.
Okay. If we can read it.
Stop moving.
Let's see. So I'll start us off. January 6th of 2009, President George Bush established the Pacific Remote Control.
Pretty much
Pacific Remote Islands Marine National Monument.
Most of the day.
By presidential proclamation.
Do you guys feel comfortable with this heading? We have about 10 minutes to reach the bottom.
Yeah, we got to stare in the dark here to try to read this. Hey, wait, I got my flashlight. There you go.
Where?
Other side, you're on the back side. Wait, what did you get? Oh, we only got one copy. That's the rest of it. Sorry.
So you're reading one page and I'm reading the other.
That's right. All right, I'll do a little bit more. The monument, and then I'll switch to you because you got the rest of it. President Barack Obama expanded the monument on what date? September 25th, 2014, with another presidential proclamation. So now the monument around Johnston goes all the way out to the 200-mile exclusive economic zone around the island. It used to be 50 nautical miles out from it. So, and then Jarvis was also...
Go ahead, Bridge.
I'm trying to remember. Jarvis was also expanded out 200 miles, and so was Wake. And then Palmyra and Kingman remain at 50 miles, and so does Howland and Baker.
So we're part of a 3-year campaign to study this area. This is part of what's called the Capstone Campaign, the campaign to address the Pacific Monument, science, technology, and ocean needs in order to sort of collect deep sea baseline information that will inform on science and management decisions in and around the U.S. marine protected areas in the central and western Pacific. So we're currently south and west of Hawaii. The Pacific Remote Islands Marine National Monument includes about 1.3 square kilometers of submerged lands and waters.
1.3 square kilometers?
1,269,65 square kilometers of submerged lands and waters.
That sounds a little better. Early morning math, yeah.
These ecosystems include, inside the monument, include Baker, Howland, and Jarvis Islands, Kingman Reef, as well as Palmyra, Wake, and Johnston Atolls. These 7 islands and atolls are designated as national wildlife refuges and sustain a diversity of species, including corals, fish, shellfish, marine mammals, seabirds, land birds, insects, and vegetation found nowhere else in the world.
Interesting.
So we're not going to see any of those on this cruise, you think, right?
Land birds?
Yeah. Well, we see land birds, that's right. We're really not going to see too many insects down around 2,000 meters. What do you think we're going to see today?
Today, I fully expect to see innumerable numbers of deep-sea corals, sponges, and starfishes devouring all of those things. But if we're lucky, we'll get to see a couple of the more unusual players on these ecosystems, such as giant sea spiders. Maybe we'll see something we've never seen before. Maybe we'll get to see some cool cephalopods, which have been noticeably absent from most of our observations. So I have high expectations of every dive, and I'm rarely disappointed because we always see something interesting.
Yeah, that's the cool part of doing these dives is you have no idea what you're going to see. And while we see some of the same players on every site, we see a lot of different players, and we see the combination of players. How do I want to say this? There's a different combination of players on every single seamount we visit. So it's really fascinating to try to figure out how the communities actually developed on these seamounts when they're not that far apart, and yet they can be very, very different.
That's right. And one of the big parts of how we study these areas is trying to understand the communities, the species which live in these areas, and what types of environments are supporting them. So yesterday, for example, we saw sort of an elevated pinnacle, a magma-formed area of high aspect, lots of cliffs, lots of blocks, lots of areas that were sort of lifted into the water current, and so we saw lots of filter feeding and sort of stocked animals which take advantage of that kind of setting.
Yeah, so also on a serious side, the dive today and the dive yesterday was made possible by the Schmidt Ocean Institute ship Falkor, along with the University of Hawaii, specifically Dr. John Smith and Jonathan Tree, who mapped these seamounts in this monument back in December and January of this last year. So without that data, we couldn't have dove on these seamounts. We're going to try later this cruise to do some really quick mapping and then dive on some seamounts. It's going to be really hard to coordinate all of this, but we thought we would give it a try. But normally, we need the seamounts mapped before we'll dive on it. And thanks to them for actually providing us the data. Not only mapping it, but providing the Okeanos with the data. It made all of this possible. So kudos to you guys. That's a Hawaiian term, and we really appreciate it. You never heard this? Yeah, kudos. Like,
go ahead, Nat.
Oh, you're not. Sorry,
right now we're reaching bottom. We haven't gotten there yet, but I wanted to update you on the bailout, which is going to be 090.
Bailout of 090.
So that kind of means like high five or whatever you want to say.
Very accurate.
Very common.
All right.
I see.
Serious altitude, 100
The main thing I want people to remember is Pacific Remote Islands Marine National Monument. And think about it, remote control. Johnson Channel, Wake Channel, Jarvis Channel, Palmyra Channel, Kingman Channel, Howland and Baker Channels. Take your pick. They're all spectacular atolls, fantastic combination of land and shallow water marine species as well as really deep water species that we're investigating right now. So really cool place to be.
Yes, especially as we get down to the bottom where the water is near freezing.
Oh, jeez, that's right. Just a little bit of dark humor this morning.
Are we? Oh,
7.5.
Sorry.
we're under all
enough-
kinds of pressure
enough of
to do
that.
these kinds of things.
Okay, enough. All right. That's it. We're not going to torture.
Is it the bottom
anybody
yet?
else. Yeah, I think we got bottom already. I see that Tina Molitsova has joined us in the event log. Good morning, Tina, or good evening. I'm trying to think exactly what time it is in Moscow right now, because Tina is participating probably from home at this time, but she's with the Shirshov Institute of Oceanology
60 meters
in Moscow. And we are hoping to find some black corals today, which were conspicuously absent yesterday.
Yes.
So,
although, as a person who likes to treat all metazoans equally, I hope that the starfish we find are eating those also.
I'll stop 50 meters altitude.
well, the only thing I can think of is we need to at least remove one of those beasts from those corals, and so we're kind of saving a few of the corals if we remove one.
You're putting a good spin on it.
Yeah,
we'll see how it goes.
Bridge, this
right,
now.
so
Go ahead.
Can we change the center of rotation to the A-frame right now?
You only have to listen to this
Sure, I will change that.
ridiculous
Thank
initial
you.
banter for another minute or two, and then we're going to get a little more serious when we see the bottom.
And happy Saturday to everyone.
Yeah,
ROV
happy
nav
Saturday.
bridge.
Believe it or
Center
not,
rotation has
it's
been
easy
changed
to
to the
lose
A-frame.
track when we're out
Copy
here at
bridge.
sea
Thank
of
you.
what day it is, and so it's good for us to remember.
Ready for me to back up? Yep, I already have you in pipe. Nice. It's here. And I'm
So,
back.
Mashcore, I didn't even point out the actual dive site, which is on feed 3, right, to the general public?
That's correct, Chris. Right now we are looking at Flitterwell screen on stream 3, which is showing you a beautiful volcano mapped by Falcor last year, and we will be diving. We'll be starting our dive right about here in this flatter portion at a depth of about 1,560 meters, and then we'll be climbing up through this first terrace, and then there's another terrace before we get onto the top of the seamount.
So, Mashcore, by the way, when we were repairing the cable the past few days, you managed to map for the very first time how many seamounts?
I think we have completed mapping of about 4 seamounts for now.
Wow.
Yep.
So just while we lost a couple
see
days
you,
there from the
getting closer
video
to the
and
tight.
the actual imagery, Mashcore was hard at work with his team, actually being extremely productive in mapping more of these seamounts in the monument itself, and it's beautiful data. It's really great.
There you go. Coming into fisheye.
So Dr. John Smith told me that he expects this kind of flat dome-like structure that you're looking at, if you're looking at feed 3, to be volcanic. A lot of these flat top structures are the result of the seamount being above sea level, and it gets flattened by erosion and by coral reef development. But in this case, he thinks this is what's called a pancake volcano, and we will be able to determine that almost immediately, because if he's right, which I think he is, we should see pillow lava. These are volcanic lava flows that have erupted underwater, and they come out like big, huge toothpaste tubes. And I think we're seeing the bottom already. And I see, no, sorry, just a floating creature. So anyway, we will be able to see if that's a correct hypothesis.
You're there?
We are also on this particular type of terrain because we expect it to be heavily manganese-crusted. And some point in the future, 50 or maybe 100 years from now, there may be a need to consider mining some of these seamounts around the Pacific that have this type of topography, fairly flat summits where machinery could actually do their work. So what we're trying to do here on the Okeanos Explorer is just start exploring and getting more data on manganese crust communities. Manganese crust, it's a crusting on the rocks, is what the mining industry would be going for. But in our case, what we're just trying to do is produce some brand new data, explore some new seamounts, and just get some baseline information on these communities that we think is going to be quite useful.
Watch lead video. If I can just jump in here and interrupt for a second.
Sure.
After your pre-dive warm-up that you guys just went through for everybody, it might be a little late to remind you that you and everybody on the science line that we are recording it, we will be archiving it, and it is going out to the general public on the internet. So thank you for the show. Have a great dive, and we'll see you on the flip side.
Yeah, thank you, video. And is there any chance you can sort of edit out our worst jokes? So is that possible, or is that not possible?
Because we haven't done the worst jokes yet.
Oh dear! Apparently that's not possible.
Almost there.
Oh boy! All right, we're gonna have to behave a little bit today, I guess.
All right. These are coming down.
You know, we joke around. This is very, very serious business, but we just want to have some fun out of here and make it light for all of you in the general public who might be watching.
And Chris, if you could do me a favor, I'm not on anything. Just you're force talking me on video, please. If you could release it. I thought you would.
Someone.
Right, you got that, Bob. Go ahead, Chris.
Going down pretty quick. I'm trying to catch up. Sorry, I'll back down. That's fine.
I may have you guys mixed up. I'm good now.
Okay, thank you. Yeah,
you're. I bottom.
think you're off.
Yeah, why don't we slow down?
Oh, you are. Okay.
Tether's starting to come up. I could just pause here. We'll let it sink for a second. Okay. I'll just stop as well. Yeah, so got to dip in. Lateral port a little bit. I'll let that tether sink. I see bottom on my sonar.
I have visual.
Anyway, yes, so shortly, I think we're seeing the bottom right now.
All right, we can continue back down.
All right. So Tina Molotsova said she is definitely joining us from home. It's about 10:13 in the evening, her time in Moscow. So thank you so much for joining the dive, Tina. And like I said, we hope to find some animals for you. And I think the bottom's coming into view.
Yeah, well, actually, that's right. Coming up on bottom now. Should just be a couple more moments.
Yeah, great. Thank you.
High pack looks pretty much dead on. Yeah.
There's something I forgot to mention in our introduction, and that is that this is going to be another dive where we're going to come up maybe a little bit early,
let you know that we just
some
reached
midwater transects, which are going to be really cool. So what you're going to get a chance to see here, if you stay with us today, is to see a whole variety of benthic animals that are living on the substrate. And then later on this afternoon, at the end of the benthic portion, we're going to go up into the water column, and we're going to get up to 800 meters, so about half the distance to the surface. And then we're going to start a series of lateral transects, and they're going to zoom in on jellies and weird fish and all types of cool things, like fauniphores, ctenophores.
Yes, all the things that live in that three-dimensional space above the bottom of the ocean.
Yeah, and we're delighted to let you know that we've got Dr. Mike Ford, who's going to be hosting that show for you, and he knows a lot about these animals. So you can definitely learn a whole lot of what's in perhaps the largest ecosystem on the planet, which is the deep water, midwater ecosystem. And possibly the most poorly known of any ecosystem on the planet as well.
Still have,
I don't know what to make of this substrate, quite frankly.
Come down slow.
Oh, I know. Okay, we probably started on near the actual Cretaceous summit, and then we'll go up some ledges.
That's a lot for me. I'm going to turn to port to try to correct this.
Very interesting looking rock on the right side there.
Yeah, well, actually, just a couple more moments. We're just getting
the
tether
fine.
situated.
I'm just idly.
Great. Thank you, pilot.
Thank you.
So Nicola Rodriguez just joined us. She's been on my left the entire cruise.
Okay, that's
and I have a question for you right out of the gun here. Nicola.
Okay.
So I use the word kudos. Now, you want to explain that?
Kudos?
Kudos.
Well, kudos is just kind of giving props, isn't it?
Yeah, that's what it is.
Totally.
That's what I did. Chris and I hadn't heard of that before, and I just...
it was a little
I also
bit
educating him on some good slang. I like it.
You've been trying to teach a bunch of the ship's crew and everybody a few Hawaiian words on this cruise, haven't you?
Yes, I have. Absolutely. Bringing a little Hawaiian culture to the cruise.
Yeah, absolutely. Because we are only about 800 or so miles from the main Hawaiian Islands, so we're pretty close.
Yes, we are.
Okay. All right, you're happy? Thrilled.
All right, we've got a mixed substrate of sediment and looks like some boulders and cobbles that could be manganese nodules, or it could be hard with just sediment dusting in between.
All right, watch leads. I think we're pretty much situated. If you see anything that pops out, just give me a heads up and I'll get a good look at it.
Great. Thank you much, pilot. Well, let's go ahead and start going somewhere. I'm not seeing tons of targets right off the bat.
Yeah, copy that. Okay. Yeah, Nav, what direction do we want to move first?
Bearing is right there displayed on HIPAC. You are...
Might be something pilot on that boulder over there.
235.
Copy that. 235. I think we get a move in.
Oh, I think we do have an animal.
Ready.
Copy.
I'm ready.
All right, great.
All right.
Okay, we got our
20
first
meters?
animal of the day on the benthos.
Two animals, looks like.
Is it two?
Okay.
I think it's a Metallogorgia or something.
Excuse me. I thought it was the stock and the... Oh, yeah. Okay.
There you go. You saw something in the back. So we're going to get a close-up of this to confirm its ID.
235. I'm going to follow you.
No, actually, sorry for that. Target bearing is 262.
Pretty sure I know what it is, but...
Okay.
All right, video, come on in.
262.
And yes, so this is a octocoral, a deep water coral that's in the family Chrysogorgidae. And we see a lot of members of that family in the genus Chrysogorgia, but this isn't one of them. This is in the genus Metallogorgia. And I think it's given that name because it has this beautiful metallic, shiny skeleton underneath that tissue. And I'm madly typing this into the annotations.
You'll note that there's another animal coiled around the branches on the internal part of that coral, and that's a serpent star, a member of the Ophiuroidea. These are distant relatives of sea stars, and these have sort of a fleshy skin covering sort of vertebrae-shaped ossicles or bony parts along the arms, and this gives them the ability to have a really strong sense of flexure. They can coil their arms around the branches of these corals. And these are often very close relationships, both physically and ecologically. These animals are seldom, if ever, found free-living. These are always coiled around their host coral. And in fact, they're so tightly wound that even when these specimens are collected or found dead, in museum collections, for example, those arms just don't come off. They're wrapped around those things even unto death. So really just a very remarkable relationship.
And for those of you who might be interested in what the oxygen levels are, right now it looks like we're at about 1.6 milliliters per liter, and that'll make sense to folks who monitor this oxygen. But as sort of a general comment, it's pretty low here. It's not right at the lowest point that it gets on this particular seamount. We passed that around 550 or so meters, where it got down to 1 or just under 1 milliliter per liter. So how to put that into perspective? At the surface, the oxygen is generally around 6 milligrams per liter, maybe even as high as 7 sometimes. So it's much, much lower oxygen content down here in deeper water.
All right, science, are we good on this one?
Yes, we are. Thank you,
Great.
pilot.
Video, come on. Great.
And there was a large whip in the background there.
Copy that. We might not be able to get there just yet.
All right. Do you feel comfortable with the move
Great,
right
thank
now, co-pilot?
Yes.
Okay.
Yeah, put it on.
Brakes is enough.
Go ahead, Nav.
Let's go ahead and get the first move in. That's going to be 30 meters, bearing 260, speed 0.2.
That is 30 meters, bearing 260, speed decimal 2.
Copy.
Yeah, watch it. It's just right out of reach right now. We'll come back to it, though.
Sure, that's fine. Thank you.
Tina notes that there is a small sponge to the left of that Talagorgia we just looked at.
Oh, I didn't
Starboard
see
upper
that.
swing arm, so it might be a little dark on that
Washington,
side. I
what
tried to
structure
make
was
up
that?
for it with the others.
Oh, it's back where we are. It's no problem.
He's
She
wondering.
just spotted it on the close-up. So we always say this for those of you
RV
who
nav
might be
bridge
new
move
to
of
the
30
Okeanos
meters bearing
Explorer
260, speed
dives,
decimal
but
2
those two
initiated.
red dots
Thank you,
are
bridge. Copy.
lasers that we use to get an idea of the size of things down here. They're just little
that
red light
262?
spotches. They don't hurt anything, and they're 10
260.
centimeters apart.
260,
Just about on it.
So it really helps us to figure
Yeah,
out
all
how
your
big the
cameras.
corals and fishes and rocks and everything else are.
Oh, what's this?
Hydraulic secure.
Put that in the background there, that white thing.
Dock of some kind.
I don't know if we could get over to that.
That's also
A little far?
away.
Oh, no worries.
Get a little closer.
We'll get to it eventually, I'm sure. We're
It's
coming
a
on
sponge,
some...
I think.
Oh, there's some urchins on the right.
Where?
Sharpshooter Annie sees it again. Over here.
He's going to ignore the sponge, I'll bet. You just intercepted my sponge.
We can get both. Don't worry.
Okay, thank you. Phew. That was close. Not sure it's an urchin, though.
Oh, yeah, they could be rocks.
Video, quick
No,
zoom.
it's something else. Something's on it, but...
Oh, we're both wrong. It's an
It's
Anthomastus.
Tina, I don't know if
She's here.
if she can. I know she is, but we
Yeah,
got your
it's
animal
already
coming
about
up,
to
so
shut
stay
down.
tuned. One of her animals.
DT-CTD.
You've got a little long-legged shrimp right next to it,
Installation
too.
resistance testing.
If you think it'll be okay without interfering with the data too much, yeah, go ahead.
Well, we have the profile. You're off to my starboard a good bit.
That's a long-legged shrimp. Yeah, it
I'm
is.
gonna bring that down.
So what we're looking at is a soft coral.
Just like to confirm it at
These
depth.
have these many mouths, some of which are closed right now. They're surrounded by 8 arms each, and these are all part of a colony. They all sort of center on this large mushroom-shaped structure in the center.
It's really right at the end of my
This
leash.
is a colony of
Stuff for me to
animals
get,
called octocorals.
settled.
One of our shore... So for those of you who might be unfamiliar with how all of this works, we're working out here on the ship, but we have a talent pool of some of the world's experts on different groups of animals as well as topics.
Co-pilot, do you feel the swing already, or you haven't started
They're
yet?
accessible to us via telepresence,
I
via
haven't noticed moving yet.
Okay.
phone lines and other accessible ways. And so one of those scientists is Tina Molotova
Come down
from
a little bit.
the Russian
video.
Oceanographic Institute, or
let's
the
do
Shirshov
this.
Institute of
Quick shot of
Oceanography.
this.
And so one of her
And then when you're
areas of
happy,
expertise
come on
is
out.
mushroom corals, which is what this is.
So she ID'd it as in the genus Anthomastus.
Yes.
So
Okay.
thank you, Tina.
Yeah, just one more second, science.
Sure.
Okay, now G2 CTD is back on.
Copy.
All right, video. Are you happy with that?
Great.
All right, we'll go to sponge next.
So, Chris, are we doing rocks today?
We are if we see any good ones, but this all looks like manganese crust.
All right.
I have definitely got an eye out for rocks.
Very good.
This is a little bit of a curious one. I'm pretty sure I can
Ship's
do a
going
family.
to
It's
stop
almost
momentarily,
certainly
co-pilot.
a rosellid
Okay.
glass
I
spear.
think I've
Zoom
started.
from here. It's as far as I can get right now.
I think that'll do it from here, pilot.
Copy.
You should have a little more leash.
Got a little
Never went
depression
further
in the
with
front
full
face of us. This is in the genus
Video goes in.
Calophacus. It's a
RV nav bridge,
standard,
we're
I
complete.
think, Calophacus.
Copy, bridge.
Calodiscus. The Calophacus genus is not well. There's a lot of members of it, but it's not taxonomically resolved right now. So there's a lot of subgenera in there rather than species. And so this one this is a little bit different because it's got a bit of a dimple right on the center of it. But so I think just going to genus Calophacus is about as far as I can go on that.
Did you see that little bit of, I don't know, that white, was it a bit of debris that's on the stalk, or is that an animal? Well, if we can proceed down the stalk a bit.
Yeah.
Yeah, at your convenience, of course. Thank you.
And is that a crab or something?
Not sure.
What is that?
It's like debris.
Sorry, video.
It's a little tough because he's kind of at the end of his tether here as he's doing this zoom for
no,
us.
I
That's
definitely
the issue.
Yeah, all you need.
Or is it a crinoid that's lost a lot of arms?
Oh, it's a brittle star.
A brittle star, yeah, okay.
Interesting.
It's
Huh.
debris.
Yeah. We're good, thank you, pilot.
Copy.
Maybe we can spot something that's actually closer to the vehicle this time.
Yeah. So we've come to port. To starboard a good bit.
Yeah, no, come back. Don't worry about it.
So what's going to happen here is we sort of purposely started on a little bit of the flat part of this particular feature, and then as we cruise uphill, we're going to get into some steeper topography, and that's where we really will hopefully get into some volcanic rocks, as well as some other animals. This is not unexpected, let's say, because a lot of the flat tops of these seamounts have got manganese nodules and a fairly sparse group of animals.
Oh, that's good to know.
Yeah, so, you know, one of the most interesting things for me is to see these transitions, you know, as you go from flat cobbly to steeper. That's where you start to understand what's important to these animals down here, what they're queuing in on.
Yes, and as we move forward, we're seeing there is actually some life, just sort of out at the along the
If you
edges.
see any potential rocks you want tested, just let me know.
Yeah, I will, pilot. I'd like us to get into some really clear pillow formations first
Copy
before
that.
we collect. So thank you. There's
Okay,
a big
you're
colony
centered
way
up
in the
now.
back there.
Nice.
I don't know if it's dead or not, but let's take a look at this whip if you can get to it. call these things whips for obvious reasons.
Looks like this is another bamboo coral.
All right, video, come on in.
So bamboo corals are called that because the skeletal support that you see running through the middle of the animal is white with dark internodes, with dark bands. And so when the tissue is removed, these give off the appearance of being sort of bamboo in appearance. But as you can see, what we're looking at is a whole bunch of feeding polyps. These are the mouths of the animal. This is a colonial form. And there are 8 arms around the mouth. Each one of these 8 tentacles has little structures that come off of it. These presumably help the animal feed on organic particles in the water as the current brings food.
No, you can stay there. It's fine.
Doing it for tether management.
Copy that.
Can see that Steve Auschwitz from Temple University has joined us. So good morning, Steve, or good afternoon where you are, and thanks for joining us today. So I don't know how to determine what clade this bamboo coral is in. We don't have our premier bamboo octocoral specialist with us today since it's Saturday. And for some reason they prioritize their families, I guess. But anyway, the video that we're getting will be extremely helpful for them to get a better ID. So thank you very much, Pilot. We're good in science when video is.
Copy that. All right, video, come wide.
Oh wait, there's a little. I'm sorry, that little red thing right on the coral there.
We need to look at that. If we could.
Yeah. Is that what I think it is, Chris?
Yeah, I'm pretty sure it is.
Oh, neat. So I think jellyfish, right?
Yeah, that's right, the predatory jellyfish.
Score!
Closer.
You're still okay. I'm right over top of you.
Copy.
All right. Not even 30 minutes into the dive, and we found one of the predatory jellyfish. So this is
Aegina, that's right. Aegina citria.
Aegina?
Yeah, that's what it's called. It's in the Aeginidae.
Okay. So if I remember correctly, this is a jellyfish that actually hangs on. Does it actually hang on the coral or on the undersides of cliffs?
The jellyfish?
Yeah.
No, it lands. It eats the coral.
Oh, they're actually predatory.
It lands on they're predatory.
Ah, okay.
Yeah,
so this is an unusual circumstance of a jellyfish, usually a swimming or pelagic animal, that lands on coral and devours the polyps. So it's...
Yeah, how weird is that? I mean, jellyfish are usually floating around and just capturing things, and this thing lands on these bamboo corals and other corals as well and starts eating them. It could stay on this polyp for ages and get enough energy and food. Once it's found the right coral, boy, it's set for life.
You'll notice also that some of the polyps adjacent to it seem to either be closed or perhaps even have been fed upon already.
Yeah, I think you're right. It looks like there's some tentacles missing.
Yeah. Okay.
Yeah. Well, thank you very much. Good eyes, Chris. That was amazing.
Video, come on wide.
That's the first one of those we've seen this cruise. We've seen them on other cruises, but I don't think we've seen the predatory jellyfish before. Now there is a whopping big thing in the background there.
Yes. I'm always good on big whopping things. Let's go see what it has to offer. At your convenience, of course, Pilot.
Yeah, copy that.
It may be dead, but it looks...
No, you never know what's kind of... People find all sorts of great things in haunted houses.
Yeah.
Copy.
Well, I think there's some live tissue, but I don't know if one of your beasts has been on this thing.
There's a whole bunch of things, though, that could be feeding on it. Those jellyfishes.
Yeah, but yours are the worst. Yours are the worst, though. Yours are just voracious. Never satisfied. Not
starboard, upper does
not just willing to take a polyp.
You know, all you're doing is flattering me, right?
Demonstration.
Okay. Well, it's pretty denuded.
Actually, there's a
upper
things growing on it.
Yeah, a bunch of things that we can take a look at. So even when dead, these big corals serve as home to a lot of other animals. Well, I'm not sure it's completely dead.
Alright, video, come on in.
Hydroids, I'm guessing.
Yeah, I think so, but that's just one of a variety of things.
Oh, sea anemone.
Yeah, go for it, Chris. How many of these animals can you see here?
So we have squat lobsters. We have Ophiacanthid brittle stars. We have several colonies of hydroids. We saw sea anemone. So that's 1, 2, 3, 4. Yeah, so the skeleton of these animals have already provided 4 species of other animals with a temporary, or at least a home, at least. The brittle stars like to climb up onto the, and there they go, jumping off again.
Look at that. Why did they do that?
They were doing this when we saw them during, or a few, months ago. I think that's Ophioplanthaka. I don't know why, but they seem to, I'm not sure if it's the lights or perhaps the ROV does something, vibrations in the water, but as soon as we approach, they sort of like to jump off of the coral. But yeah, they climb up high into the branches, presumably to take advantage of the current, since there's nothing on this to actually feed on. The spines are quite sharp, and so I think in other cases on living organisms, they actually sort of take some of the tissue off as well. The hydroids are on the top branches of this bamboo coral, and they seem to be taking advantage again of the water current away from the bottom. I've never figured out what exactly squat lobsters eat. Presumably, again, it's just stuff in the water as it's swimming by, or perhaps they feed on the hydroids. It's hard to say.
Yeah, so this squat lobster is pretty poorly known. We call it Galathoidea, long-armed spiny. How about that for a specific name? Yeah, sometimes that's the best we can do.
Oh, yeah, sorry, go for it.
Yeah.
So they're going to get a zoom on this guy, and some of the hydroids too.
Oh, there's a barnacle on there too.
Yeah, barnacle. That's right.
Our long arms.
So the barnacles are crustaceans, believe it or not. A lot of people used to think that they were like mollusks, but they're in fact more closely related to crabs and other things. And what you're seeing there is the animal is sort of upside down. Its head is stuck to the bottom, and its feet, its arms, are what they use to extend from that shell and capture food from the water as the current swims by. So even when you're seeing, so this one looks a little unfamiliar perhaps from the acorn barnacles you might see on seashore habitats or on dock pilings or whatnot. But there are 2 types of barnacles, sort of acorn barnacles and stalked barnacles. And so these stalked barnacles have this thick, what's called a peduncle, or a stalk, for simpler terms, that attach them to substrates. Certain kinds of stalked barnacles in shallow water are actually considered a delicacy in Europe. Okay, well, so the 2 feet, or the feeding arms, looks like they've gotten wind of us, and I guess, we got a nice shot of the brittle star mouth there. The teeth coming out of the bottom. Hard to say what they're for. Anyway, Chris, are you good with this?
CTT file is growing, everything's okay, even though it's not plotting, right?
Also interesting for people who like to look at dense aggregates of animals, there are tubes on the surface of this bamboo coral, which look like they might be more polychaetes. So again, this even in death, this bamboo coral skeleton serves as the home for now 6 species of different types of invertebrates. Squat lobsters, brittle stars, hydroids, these tube worms, barnacles, sea anemones. It just goes on and on. It's a panoply.
So science is good if video is good.
Copy that. Video whenever you're ready, come on out.
Yeah, we want to see if we can get into some better hunting grounds here. It's a little sparse here today. So we're hoping to get, there's a crinoid. Would you like a look at that on the rock.
Now
there.
let's move on to the bigger game.
Okay.
Find us a nice rich
now
field of things.
Do we get on the move in? It's kind of race across.
Yeah, I'm
this
right
area.
over you, but sure, you can make up ground. We can get that in now.
Do you want a 15-meter move or 20-meter move, co-pilot?
At
30
least
meters,
30.
I think, yeah.
30 again? All right.
Yeah, keep it going.
No, I have yet to see anything that's clearly a pillow lava here, so at least
Bearing
this
60,
we've got a
speed
coral
0.2
here, pilot. I don't know
coming
if you
up.
could zoom on it
Right.
while we're going by.
You got something pretty good to your right.
This is a little different
See that?
from what
Snap
we've seen.
zoom.
Oh, and there's a live one too.
Bridge,
They
this
appear
nav.
when we decide
Go
to
ahead,
zoom.
Nav.
Let's get the same
is a
move in.
cryptoid
That's going to be
octocoral.
30 meters, bearing 260, speed 0.2.
30 meters, bearing 260, speed decimal 2 coming up.
Tino is
Good copy, thank you.
commenting that the dead bamboo coral is like an oasis on this type of substrate. So I guess this is probably Narella, in the genus Narella.
ROV nav bridge, move of
One of
30
the
meters, bearing
genera
260,
in
speed
this
decimal 2
deep
initiated.
water octocoral
Copy,
family.
bridge.
Here's another very attractive looking stock barnacle with its legs extended.
That's a scalp pellet, I think, if I'm not mistaken.
Yes, I think, was it Scott yesterday who told us that these have the dwarf males inside? These are the females, and the dwarf males live sort of within them and provide sperm to them.
If you have a minute, Nav, maybe we can try to figure out
partial. I'm going to come up, reposition real quick.
with the mappers if there's anything going on that would affect the
Video come
USBL.
partial.
Copy.
It's,
Nice.
this is we should have great
Cool.
returns here. It's flat. There's a little bit of
And there was
sand.
something to the right. I think it was a
Jumping
live
all
one of those big bamboo corals that was all overgrown.
Okay.
Yeah.
The larger one?
Yeah, I
Size?
think
Yeah.
that's maybe the same thing. You could take a zoom, and there's a chrysogorgid at the base.
I'm hoping that this is sort of the
All right, video, zoom in.
forewarning that we're entering a rich, productive area.
Yeah, I hope so. It's starting to pick up. Yeah, this is definitely a live version of that. I don't know if it's the same thing as the taller one, but
It's bamboo coral, right?
yeah.
I don't see the inner. Oh, there they are. The
Yeah,
inner
there they
nodes.
are.
Okay.
so the branching is. Pilots already know to zoom on the branch points because they know that's critical for this family of coral. And that looks internodal to me, I think, which means that it's branching between the black bands that you see periodically along the stem. And that's informative. That will help the specialists in this group of corals figure out what this is. Thank you very much, pilot. That's
All right,
great.
video, come on when you're ready.
Dry lab, this is Nav. Do we have any of the ROV guys out there or Mashcore?
I think I missed that. Nicola was saying there, she thought she saw something behind it, but we're going to go ahead and move.
Sorry,
Yeah, it's
can you
just
come
an
again?
anemone, I think.
So no interest signs. Keep moving.
Yeah, we'll just keep going.
Copy.
We don't believe Nicola. No, just kidding. She's got.
I believe in Nicola. E pluribus Nicola.
Only a taxonomist would say something like that. E pluribus. That was good. I'm going to use that.
So there's a dark spot right in front of us.
There's a lot of dark spots.
I mean, there's a patch, but that looks sort of darker than the rest.
Annie, your reputation is at stake. She pointed this out. This better be an animal.
All right, video, come in.
I don't know, Annie. Ooh, busted. No, she didn't get it. But boy, has she nailed some good stuff the past couple of dives there. But not that time, Annie. That's Annie White, who's doing the video clipping that's right next to Chris Ma. And I'd like to have some fun. Pilot, would this be a good opportunity for you to introduce who's up there in the front row?
Yes. Yeah, in the front row, we're all from the Global Foundation for Ocean Exploration. Sitting pilot is Sean Kennison, and I'll let everyone else introduce themselves, starting with my navigator.
Hello everybody, my name is Fernando, sitting as navigator.
Co-pilot, Dave Casagrande.
Over in the video chair, Bob Knott.
And in the clipping chair, Annie White.
And who are you next to me?
This is... sorry, he's just taking me by surprise. I'm looking at something. So this is Chris Ma. I'm a scientist at the Smithsonian's National Museum of Natural History. And you are?
I am Chris Kelly, and I'm a biologist from
All
the
right,
University of Hawaii
should
at
be
Manoa,
coming
in the
to
School
stop
of
shortly.
Ocean and Earth Science Technology. And who's next to me here to the left?
And I am Nicola Rodriguez from the University of Hawaii at Hilo.
There's a
ROV
brown
bridge, move completely.
Copy
thing
bridge,
coming
thank you.
Or a red thing, you mean?
Yeah,
Yeah.
a red-brown thing.
lower
Red,
left.
red-brown thing.
So, Science, you want to zoom on that?
Yes, please,
Please,
if we could.
copy.
So that was your control room team at the moment.
All right.
And
video,
I
come
see
on
that
in.
Asako Matsumoto from the Chiba Institution in Japan is with us. Institute, I think. I got them mixed up. Good morning to you, Asako Matsumoto. She is another premier octocoral specialist who's been helping out a lot with the Okeanos dives. All right, Tina, you're on. We're looking at one of your babies here. This is a mushroom coral.
Rotate slightly.
That is spectacular imagery, and Tina is surely going to be able to get to genus, I'll bet, just on the basis of that image.
This is weird, though.
So what you're seeing here are feeding arms that encircle the central mouth, and all of these mouths lead down to the central colony, which is where that sort of mushroom-shaped center is present.
I'm worried about it.
Another Anthomastus.
Yeah, so good. So thank you very much, Pilot, whenever video is ready. And I see that Les Watling sneaked into the event room while we were talking there, and he actually has got an ID for that big bamboo coral. He thinks that overall it could be an ectomysis. So we'll go ahead and change the annotation record. And good morning to you, Les. He's contacting us from the University of Hawaii or home. He lives pretty close to that. But he is a premier octocoral biologist with the biology department at the University of Hawaii. It's good to see Les is here to give us a hand.
Quick zoom in there, video. Is it raining? Is there something?
Dead sponge.
Yeah, come on out then.
Yeah. What's that?
Was it the round thing? Is that what they were pointing out? That where the left of the lasers?
Yes.
See it.
Something's there.
Looks like a dead sponge.
Quick zoom for science video.
Yeah, that's good. Dead. I don't know.
Yeah.
Could be a sponge or a forearm, I guess.
Yeah, I have no idea.
Yeah.
There's a little shrimp to the left
but
there.
it is round. It's a round sediment ball. Huh.
Yeah.
Curious. Could be a sponge.
All right, I have no clue. So.
Yeah. So I think there was something on a stalk in the background.
Yeah, if you
I'm
want
not sure if it was a red or brown crinoid.
Stock in background.
Copy that.
To the right.
Actually, the target it's more like 280.
280, okay.
Oh, I see what you're talking about. Look at that. Is this our first one of these?
Is it a stock crinoid?
Yeah, I think you're
feather
right.
star on
No, this
Can you
is a
repeat that,
stock
co-pilot?
I'll hold off for
yeah,
a
it
minute on
is.
that move.
Copy.
Yeah, wait till after this.
Yeah. Is this? Yeah, this is the first stock crinoid of the expedition. Oh, and it's one that I know.
Alright, video, come on in.
But
Just about right over here.
you think?
Yeah.
Everything looks
what I
good.
thought.
Copy. Ship stopped.
So this is a stocked crinoid. There are. Oh wait, Chris, look at the stock. I don't think Proisocrinus doesn't have that stock, does it?
Yeah, it might. The key is, if unfortunately, it's a slightly wrong direction here.
Yeah.
You need to look right underneath the arms, which are kind of masking it.
Yeah. So for those of you who are just sort of
maybe a quick side view if you can manage that.
So this is we've looked at many feather stars, and these belong to the class Crinoidea, and crinoids actually come in two forms: the unstocked feather star, and then these, which are called sea lilies, or stocked crinoids. And the thing about stocked crinoids is that they are very reminiscent of fossil forms, crinoids from the Paleozoic, which are commonly encountered as fossils, are still a lot.
There it is.
Yeah.
It's Proisocrinus ruberimus.
Yeah. Okay.
Those distinctive ceria, is that what you call them? Right, right below those little stubs sticking out.
For some reason, I always remember the stock being
bring
smooth,
my
but
sonar
I
in?
guess it's not.
Sometimes it's square, and you see the shrimp that's right on the
Mine
bottom
at
there?
32 now.
Yeah. So these are very old forms, and so looking at them is really very reminiscent of kind of looking at a very old animal. These are often called living fossils. Some have argued that these were actually the motivation for deep-sea research, because prior to the first discovery of one of these animals, it was thought that the deep sea was largely lifeless. And so I believe it was sometime in the 19th century they discovered one of these, and so the notion that living fossils lived at the bottom of the ocean was implanted in, at the time, science's collective sort of interest. And so they began dredging and studying more about animals that were in the deep.
Beyond you.
These are filter feeders. They're fairly simple animals, but they have a long and interesting history. This one's called Proisocrinus ruberinus. It's very distinctive because it's red. One of the more attractive animals that we'll see as we go along in today's site.
I'm lined up on
I've seen a lot of these, but I just love them. They are just so beautiful.
Oh, they're that striking red color.
But just stocked crinoids in general are such beautiful, elegant animals.
Yeah, and these don't move. There are some of them, the isocrinids, that actually don't have a connection to the bottom. Those can actually crawl around, which is a freaky thing if you've ever seen one.
And see, this is typical. As the dive goes on, we start getting more and more scientists joining us. We now have Tim Shank from the Woods Hole Oceanographic Institution, and it's going to be afternoon for Tim. He's joining us from the East Coast. So good afternoon, Tim. Glad to see you in the event log.
Yeah, I think we get a moving now.
Yeah, it's a dead bamboo
pilots, Dry Lab wants to do a test on the USVL. You can see right there on HIPAC that it's going crazy, so we're going to increase the interrogation rate. Are you guys okay with it?
Yeah, absolutely.
Okay.
We don't need it right now.
Yeah.
Dry Lab, I'm going to call in a move, and then I'll be back with you.
So
you were thinking about the same kind of move, 30 meters.
Until just a minute ago. He commented that it could have been a xenophile for that round
280.
ball that we saw.
280.
Yep.
So, thank you, Les.
Copy that.
Les knows a lot of these sort of strange
Bridge,
animals.
this and half.
He's
Go ahead
knows a
now.
lot of the real.
Let's get another move in. That's going to be 30 meters, bearing
He also knows a lot of
280,
the less
speed
well-known
0.2,
animals, which is really
That's
cool.
30 meters bearing 280, speed decimal
He
2.
helps us out in multiple ways.
So in this case, less is more.
Okay, Dry Lab, I'm back with you.
Sorry, Les.
So originally it was 3.1. Do you want to increase it to 6.0?
That was
Oh dear. Okay, so on to the deep sea floor.
According to this, that
kind
would
of
be
a weird floor
about
here, actually, since you mentioned
3,800.
It's kind of sediment dusted, hard
Okay,
substrate. I
6.0.
don't think there's very many nodules in here. Looks like it's.
Do I have to wake up
relatively
anything? No, just
solid
started, right?
Crusting.
Okay, starting.
ROV nav bridge, move at 30 meters bearing 280, speed decimal 2 initiated.
Copy
What
bridge,
is that
thank
white
you.
discoloration there?
Yeah, I think that's what they just noticed too.
Okay.
Video zoom in.
Let me take a look at this. And it is a white discoloration. Is that whitest discolorationist, or what is that?
No? Yeah, it could be something having dug there, or it could be something